There's been a quiet revolution happening in the way we build our digital world. It's a story about a fundamental shift in philosophy, a move from building things in isolation to building them through collaboration. Let's explore how we got here.
For the longest time, this was the only way we knew. We built our applications like giant, impenetrable fortresses, a single, massive program with high walls where every single function was locked inside. It was solid, sure, self-sufficient, but also incredibly rigid. But today, that fortress has been taken apart piece by piece, and in its place, we have a team. A team of specialists, small, focused programs that each do one thing and do it exceptionally well, all working together. And this isn't just a technical tweak, it's a completely new way of thinking.
To really appreciate where we're going, we have to start with where we've been. So let's step inside that original fortress, an architectural style we call monolithic, and see why we had to find a better way.
The name itself really says it all. Monoliths, a single stone. Every feature, all the code, is compiled into one big, indivisible unit. You can think of it as a jack of all trades, a single program trying to be responsible for absolutely everything.
Let's make this concrete with a simple online bookstore. In the old world, one giant application would handle the whole shebang. The part that shows you the book catalog, the part that manages your shopping cart, the part that processes your order. They're all just different rooms inside the same massive building, all sharing the same foundation. They are completely and totally dependent on each other. But here's the thing about fortresses. For all their strength, they are not flexible. And in a world that changes as fast as ours, that rigidity eventually becomes a huge liability. Sooner or later, cracks start to appear in the walls. And this is the core frustration, the real headache of the monolithic world. Because everything is so tangled together, one tiny change in one corner of the code creates a ripple effect. It can cascade through the entire system, creating risk and uncertainty with every single update. This right here perfectly captures the absurdity of it all. The business needs a simple change. Let's just update a shipping rule. That seems tiny, right? But in our monolithic fortress, that tiny change forces us to retest, recompile, and redeploy the entire application. It's incredibly slow, it's expensive, and frankly, it's terrifyingly risky. One wrong move and the whole system could come down. And this is the question that architects and engineers finally started asking. It just didn't make sense anymore. The inefficiency was so painful that it forced everyone to search for a brand new approach. The answer to that question was a whole new philosophy. Instead of one jack of all trades, why not assemble a team of specialists? And that brings us into the modern world of services. So let's go back to our bookstore, but this time let's rebuild it using this new idea. The book catalog, it's now its own small independent application. Same for order management. Each one is a specialist. Now, if we need to update that shipping rule, we only touch the order service. The rest of the system just keeps running completely undisturbed. That means we can move faster, with way less risk. All these specialists coordinate through a central entry point, which acts like a reception desk, directing requests to the right expert. Okay, this is the next logical question, right? If we've broken our fortress into all these separate pieces, how do we keep them from descending into chaos? How does one specialist actually talk to another? Well, the secret is a beautifully simple concept, something you've probably used if you've ever traveled internationally. The secret is a universal adapter, a standard, agreed-upon way for different things to connect. Think about a travel adapter. You don't care how the power grid is wired in France or Japan. You don't need to know anything about it. You just know that if you plug your device into the adapter and the adapter into the wall, you get power. A standard interface for software does the exact same thing. It's a common set of rules for communication. As long as every service follows the rules, we don't care what's going on inside. And this is where the true magic happens. With a standard interface, one team can build their service in Java, and another team can build theirs in Python, and it doesn't matter. They can talk to each other perfectly. They use a universal language for data, and most importantly, they stay truly independent. You can completely rewrite one service, but as long as you don't change its plug, its interface, none of the other services will ever know the difference. So now that we understand how these specialists talk to each other, let's get a bit more formal and define what they actually are. What is this new fundamental building block of modern software?
This is it, right here. A service is a self-contained unit of functionality. It exists to do a job that the business needs done. And the key parts are right there in the definition. It's accessible over a network, and it communicates using that standard interface we just talked about.
This sets up a really clean and simple relationship. You have a service consumer, which is the one asking for something, and a service provider, which is the one that has the answer. In our bookstore, the order service is a consumer. It needs to know if a book is in stock. So it sends a simple request to the inventory service, our provider, which checks its database and sends back a simple, clear answer.
And when you take this core idea and you use it as the blueprint for your entire system, when your whole application is designed as a federation of these cooperating services, you're practicing what's known as a service-oriented architecture, or SOA for short. So at the end of the day, we've moved beyond the fortress. This small, independent, communicative unit, the service, has truly become the fundamental building block. It's the atom from which we now construct our vast and complex digital universe. And that leaves us with one final thought. If the service is the atom, what incredible new molecules will we build tomorrow?